Dear students, I am very happy to introduce myself. I am Dr. H. Alexis Sivaraj, Head of Department of Statistics, Thandai Periyar Government Arts and Science College, Trichy. Today, in this session, I want to introduce a concept called test of significance. Test of significance is a part of statistics. So, we all know what is statistics. So, statistics nowadays, of course, plays an important role in all the fields. Because statistics is nothing but collection, organization, editing, the presentation and analysis of numerical data. Normally we define statistics like that. Here, because as I said, statistics is the language of data. So we can collect data in many fields. But after collection of data, the data should be presented in a proper manner. That is very important. So therefore, in all the fields, data is available. Even nowadays, there are big data, so many data is available, where we must know how to process the data. That is very important. That is the role of statistics. So statistics, data can be presented through diagrammatic representation. This is one of the simple method. Presentation can be done through diagrammatic representation, like bar diagram, separate bar diagram, multiple bar diagram, percentage diagram. Even nowadays, you can see many pie diagrams. Easily you can present it. Everyone can understand very simple manner. That is one of the simplest method. Even illiterates by seeing the diagram can easily understand. That is one of the simple method in statistics, presentation of data. The second part, that collected data can be presented through graphical methods. With the help of that, we can find some statistical concepts like histogram, mosaic curve, frequency polygon, frequency curve. So these are techniques available. With the help of that, we can find some statistical constants like mean, mode, this type of thing can be calculated using a graphical method. And after that, we can apply many statistical tools available. So we have to apply the proper tools in the proper situation. That's very important. We cannot apply any one of the tools. Like we can see in our mechanic shop, you can see mechanic can apply the proper tool to use particular to open that instrument. Okay, cannot apply any one of the tool in that place. So therefore, like that in statistics also we have to use proper tool. That's very important. We cannot apply any one of the tool in different situation, because in other parts many are doing the type of, they are committing this type of mistakes. So simply they are applying any one of the tool. Okay, somebody we say even like to take this tablet for this medicine, something for some disease, something they are saying no. So like that, we apply some t-test, we apply some chi-square test like that. Should not do like that. So we must know which test should be applied or which type of calculation, which tool should be applied in a proper place. That is very important. So for that, we need some information regarding statistics. So today I am going to discuss about this type of concept only. Because under statistical tools we have mean, standard deviation, correlation. These are the different tools available that can be applied in the proper time, proper situation. That's very important. Now, after that, another important part in statistics is the test of significance. So, test of significance is not a difficult concept. That is a very simple one. But here, everything should be understood in a proper manner. If you understand properly, then you can apply application of statistics is very simple only. Okay, that is the main goal. Under test of significance, here we must know some concept of population and sample. Okay, so population is nothing but the study of the entire thing. There is a general group. Okay, and from that we can take some part of the sample. Based on the sample, we are going to give conclusion for the population. So that is the main role under test of significance. So based on the sample, we are going to give conclusion for the population. So and we have to accept it. For example, we can take rice, can take from a boil of rice, can take a single piece of rice and we will verify whether it's boiled or not. So in Tamil we will say, oru paana soothrukku oru soru padam. So we have that term. So in that case, that pot of rice is the population here. So that sample we are taking, a few grains of rice. That is the sample. So there are some large population is available, and we cannot study the population fully. If we study the population, that may affect our study. So therefore, we should not study the population fully. Only based on the sample we have to study, and we have to give conclusion for the population, and we have to accept it. Okay. Even I can give so many examples for that, for this type of study. Another example I can give. Wherever if you want to buy some grapes available in a shopkeeper, and from that just to know the quality of the grapes, just we are taking a few grapes at random. and then based on that we are giving conclusion whether they can buy or not. Okay, we can decide. So that is your basic idea. Even if you want to buy some rice in a rice shop, we will take few grains of rice and we will see the quality of the rice. So in that case, the rice available in that shop is our population. Okay, so population means not only human population. Whatever you study, okay, wherever you study, the entire thing is called population. From that we are taking some few grains of rice, okay, and we verify the quality of the rice. If you are satisfied, then you give order. If you are not satisfied, you will go to some other shop. That's all. So therefore, it is not a matter. So based on the sample, we are giving conclusion for the population. So that is the basic idea and a test of significance. So test of significance enables us to decide on the basis of the sample results. Okay, if the deviation between the observed sample statistics and population parameter. So here I would like to introduce some two concepts, that is called parameter and statistics. So here parameter is called population constants. As I said already, the entire group is called a population. So in that some statistical constants. Okay, some statistical constants can be calculated. What are statistical constants? We have mean, standard deviation, correlation. So like that we have proportion. Like this, we have so many statistical calculations are available, and we can use some notations also for that parameters. That is called mean can be defined by mu. Similarly, population standard deviation can be defined by sigma. Population correlation may be defined by rho, like that. Okay, population proportion can be defined by capital P. So these are the parameter. Okay, this is population constants for the entire group, and from that population we can select a sample. Okay, we can select a sample. So sample is nothing but from the population we are taking subgroup. Okay, from that we are taking. So samples can be selected by different methods available. Some we must know some probability sampling and non-probability sampling. So these are some techniques available to select the sample. See a different part available. Okay, how to select the sample. So there is a different part. Now I assume that the data is available, sample is available. Okay, sample is available, and therefore the sample how to proceed. So that sample population, suppose your population size is capital N, then sample size can be small n. You can define notation. Similarly, under that I want to introduce one more concept. This is called statistic. Like your parameter, statistics are nothing but sample constants. So we are taking some samples, some small sample size, n sample size. So for that sample size, we can calculate some statistical constants like mean, standard deviation, correlation for the sample values. That also can be calculated. So that can be defined in the notation x bar. Okay. So in population parameter, we are defining mean as mu, but in sample statistic, we are defining the sample mean as x bar. So that's notation very important. We should not get any confusion with that. Similarly, sample standard deviation normally defined by small s, and sample correlation by r, sample proportion by small p, like that. These are called statistic. And then we are finding samples from the population, some n sum. For example, simple example I can give. Suppose your population size is 5, 1, 2, 3, 4, 5. I want to select a two samples, sample of size 2. So in that case, how can we select from 5 population size n, sample size 2 can be selected by 5C2. So that can be simplified 5 into 4 by 1 into 2, that is equal to 10 possible samples. What are 10 possible samples? 1, 2, 1, 3, 1, 4, 1, 5. 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. Okay, so these are the 10 possible samples available from 5 population size. In that, we can calculate some statistical constants. So for these sample sizes, okay, mean for small sample group, we can calculate standard deviation. Everything can be calculated for the sample observations. Okay, so that is called statistic. That is sample values. Okay, we are calculating. Next, we are going to see about sampling distribution. So sampling distribution is nothing but suppose your population size is capital N, then sample size is small n. Okay, we are not using some notations. If you want to select a sample of size small n from that capital N, that can be selected by n, c, n ways. So it's a combination. Say for example, we can define, suppose your population size is 5, 1, 2, 3, 4, 5. I want to select a sample of size 2, that 2 can be selected through 5C2 ways. So 5C2 can be simplified, 5 into 4 by 1 into 2, that is equal to 10 ways. So how can we select the samples? 1, 2, 1, 3, 1, 4, 1, 5, 2, 3, 2, 4, 2, 5, 3, 4, 3, 5, 4, 5. So these are the 10 possible ways from 5 samples. For population size of 5, can select 10 ways. For each sample size, for each sample, for example 1, 2, we can compute some statistical constants. Statistics can be calculated, mean, standard deviations. Okay, these are things can be calculated for the statistics, for the samples. And then normally we are defined one notation called standard error. Standard is nothing but the standard deviation of the sampling distribution of a statistic. Okay, particular statistic can be find standard deviation of the sample distribution of the statistic called standard error. Normally defined. This plays an important role in test of significance, standard error. So next we must introduce. I want to introduce some concept. It's called null hypothesis. So null hypothesis is nothing but this is very important. Okay, because for any testing, okay, first part is nothing but null hypothesis. Even our human life we can verify. Suppose as I said already, suppose I want to buy a rice. So in that case, what we are doing, first we are going to the shop and then our aim is nothing but to buy rice, good quality rice. That is our ultimate aim. So in that case, we are going to the shop and we are taking a sample of few grains of rice and verify whether the quality is good or not. If you are satisfied, we will give order. Okay, if you define, that is your null hypothesis. Actually, here in our statistics, we are defining null hypothesis is a definite statement about the population parameter. It's a definite statement about the population parameter, which is a hypothesis of no difference. So normally we define like that. So hypothesis is related to parameter only, not for the sample. Okay, our aim is to buy a rice, take a sample. So therefore, we are giving conclusion for the entire plot. Okay. Statistics, we can test so many things like statistical constants, as I said already. So mean can be tested, then standard deviation can be tested, correlation, proportion. So this type of things can be done through some techniques. So I define hypothesis in the set up a statement. Similarly, suppose for example, if you want to verify whether your population mean, as I said already, notation mu, that population mean for the entire group is, okay, for example 100, I want to verify. So in that case, your null hypothesis should be, notation we are using H0 mu equal to 100, we are defining. Okay, so then from that we can set some alternate hypothesis also. Alternate hypothesis that is defined by H1. Alternate may be H1 mu not equal to that is value. For example, if you define 100, it's not equal to 100. Similarly, H1 that the mu less than 100, H1 mu greater than 100. So this can be done only in the alternate hypothesis because our null hypothesis should be always equal. Okay, b equal to 100. That's all. So alternative may be less than, greater than, not equal. Can be. So with the help of that alternate hypothesis, we can define some notation. It is called, if your alternate hypothesis of not equal type, then we say that it is a two-tailed test. If your alternative is less than or greater than, it is called one-tailed test. Okay, so these are things available and may be helpful for finding the table value. And then we have to see about some, I want to give some notation about level of significance. That is also plays the important role in test of significance. Level of significance defined by alpha, because our conclusion is based on sample. We are going to give conclusion for the population, but based on the sample. So how far it is going to be true? In practical life, we can think of. Okay, wherever suppose if you want to buy some grapes, so based on the sample only, we are giving conclusion. Suppose if you take a sample, some defect samples, that may affect your result. So that may be happen in statistics also. It is also available. Okay, it is also possible. So that is we are defining as two types of errors. Under statistics, we are defining as two types of errors: type 1 error, type 2 error. Normally we define. So what is type 1 error? Reject H0. That is reject null hypothesis. Reject null hypothesis when it is true. That is type 1 error. Accept H0 when it is false. That is your type 2 error. So we are two types of errors. It is also possible. Okay. So this alpha is nothing but level of significance is defined as probability of type 1 error. So probability of type 1 error. Okay. So similarly, beta is nothing but probability of type 2 error. We are defining notations. That here we are taking the level of significance, of course. So why we commit this type of mistakes? Okay, based on the sample, we are giving conclusion. So if you take a wrong sample, that may affect your population. Okay, so why it is so? Because that can be defined by critical region. So the region in the sample space which amounts to rejection of a null hypothesis, it is called a critical region. So if you take the sample from the critical region, that may affect your result. You can define like that 5%, 1%, that can be defined. So that is why for testing of significance, we are using alpha equal to, normally by default 5% will take. In particular, suppose if you want to verify by 1% can be done. So if we say alpha equal to 5% means we are saying that 95% our conclusion is of course is true. Okay, so 5% may be difference may be available, so like that. So here what we are going to do, so for that under test of significance, as I said already, first we are define the hypothesis, okay, and then only based on that we are giving conclusion. So null hypothesis we are defining. So for that we need some set of procedures for test of hypothesis. So mainly some 6 steps available for any test. Okay, you can apply. First we are defining the null hypothesis. So that is the aim of the hypothesis. Second one should be your alternate hypothesis. Alternative, as I said already, it may be not equal or less than or greater than. There is an alternate hypothesis. Then third one is something but level of significance. So we are defining level of, we should define whether 5% or 1%. That also should be designed. And then fourth one should be test statistic. So here under test statistics only we are going to define the formula part. So we have to apply the proper formula for the proper test. We can't apply any one of the test for, so we should not apply that. Okay, that is very important. So we have to apply proper test statistic. Okay, like for we are going for some blood test. So in that case our aim is to know some disease test. So in that case, if you go to the lab and if you say I want to verify my group test, so immediately they will think of, okay, they take a few samples from your blood and then from that sample they will give conclusion about your blood, okay, whether your blood is A positive or B positive, some AB positive or O positive like that. Okay, so depending upon that same sample they will give conclusion and we are accepting that also. Okay, so therefore like here we are going to give conclusion for the population based on the sample. So therefore your level of significance should be 5%, 1% like means 90% will be true like that with the sample. Then test statistics means in that case if you say I want to verify, you want to verify my blood test means they will give corresponding chemicals. They will add the particular chemical with that and find the result. Suppose if you want to verify some group test, they cannot mix some other chemical. Okay, therefore proper test statistics, proper formula should be applied for the proper test. That's very important. Next one is called table value. So using some test statistics, we have calculated some value is available, and a table value, some statistical table available nowadays in this test of significance can be done by our statistical software. So many softwares available. With the help of that also can be done. So table value is nothing but statistical tables available for the particular test under test of significance. If you apply your T test, then we have to refer the corresponding T table. If you apply F test, then we have to refer the F table. If you apply normal table, can refer some Z value can be referred by normal table. So like that we have to verify the proper statistical tables. And if your calculated value is less than table value, we will accept null hypothesis. That's all. Okay. So we are finally we come to the conclusion. So how can we make conclusion? After the computing of statistics, applying a formula, and we are getting some calculated value. Therefore, the calculated value, you can refer some table value, and we are comparing these two values, and we will give conclusion normally. Okay. So this is a manual calculation. We'll do this type of calculations. If you go for some statistical softwares, it's also available. SPSS or softwares are available. With the help of that, we can compute some. If you apply T test, some p value it will give. So if your p value is 0.05, suppose okay, if you are calculating some values, if your value is greater than 0.05, then we will accept null hypothesis. Okay, if your value is less than 0.05, we will reject null hypothesis. So like that you can give p values. Based on the p value, we will give conclusion. Okay, so that normally we are doing this type of things using our statistical softwares. And this is the main idea under statistics, okay, especially test of significance concept. Just I introduced some limited part, okay, and after that we have to explain about the different statistical tests available. Okay, what are the different statistical tests? We can define by small sample, large sample, because we should be very clear. Okay, before going to test of significance, so where we are going to apply, for what purpose we are going to apply the statistical test. So the type of idea should be very clear and can be divided like that. So population size, based on the sample size, we can divide a test like that: small sample, large sample, If your sample size is less than 30, it will be treated as a small sample. It is greater than 30, it will take as a large sample. So this type of testing can be done. So in detail, okay, we have to study, and especially for t-test, what are the tests available for t-test? So single mean, difference of means, okay, and difference of means we have the samples are dependent case, that's called a parity test. And then for f-test is available for small sample, that is for to test the equality of population variances. Then similarly we have chi-square test is available for the population stratification. Similarly for correlation we are using t-test to test the sample correlation. Similarly for large sample we use our normal table, z equal to some values we are available, test statistics, we can apply your large sample test. So these are the some idea under test of significance. With the help of that we can do many things, because normally wherever you apply data is available, and if you want to give some conclusion, just apply your statistical tool, it will give some answer, and based on that if you give conclusion, everyone will accept it, because our statistical techniques are scientifically proved techniques. Therefore no need to worry about it, you can directly apply our statistical tools, but you have to apply your proper tool in the proper situation. That is very important. So test of significance plays an important role in statistics. So therefore in next sessions I can give in brief manner about the particular test. Okay, so how to apply your different t-test and the chi-square test, f-test. Okay, these are the different things available in the test of significance that we'll see in next sessions.